So how did 1-3 go? The distance and midpoint formula has a lot of uses, so I really hope that you took the time to get good at it because it will come in handy, especially when we start talking about triangles and four-sided shapes and so on. So it's very important that you understand how both of those work. For 1.4, we're going to talk a little bit about angle measure and kind of what that means. So how does an angle get created? Well, an angle that most of you might have seen would just be something like this. That would be how probably most of you would recognize an angle, something like this. But what you have to understand is that there's a couple of pieces that come into play when you make this. The first part is this idea of a ray. A ray is a part of a line, so remember lines extend on forever. And the difference is that a ray starts at one endpoint and then goes on forever in one direction. Okay, so a symbolic representation. So if I have, ray AB, or if I say something like this, starting at S and going like that, it will go like this. Okay, so that would be considered a ray. That would be considered a ray starting at S and going through X. Okay, so that's how a ray would work. Now, if I wanted to say something like ray TW, that line didn't really go through W, but you understand what I'm saying. I would have to say that. It starts at T, so this is one of the big differences here. For a ray, the first point is where it starts, and the second point is where it goes. So that would be different. That would be different if I said, WT would go this way. So this would be ray WT versus this one, which would be ray TW. Okay, so order matters in this situation. Order matters in this situation. So an angle then gets created by two non-collinear rays. Okay, so they're rays that are not on the same line. Okay, that meet at a common point. So if I said that I have an angle, and I will say that angle is ACB. Okay, that is angle ACB. So this is created by, made by ray CA and ray CB. Okay, it's made by two rays, and my vertex would be at C. Now notice, in my angle here, my vertex is in the middle. Okay, so it kind of like tells a little story. I'm starting at A, I go into C, I come back out B, and that's kind of where my angle comes from. Okay? So usually three is enough to say. Sometimes it might also just be called angle C. If it's very obvious which angle you're talking about. Sometimes people shortcut it and just go by one angle. But technically 3 is the correct way. 3 points is the right way to do it. So a couple of parts that you need to be aware of. Let's go with this one, mixes in. So you have 3 distinct parts when you have an angle. Okay, so point C, B, and D lie on the angle. Okay, which makes sense. I mean, they help create the angle. That makes sense. Point A lies on the exterior angle. That makes sense. That just means that it's outside of the angle. If you think about the exterior of a house, you're talking about the outside of the house. Okay, point E then is going to be on the interior. So that's going to be on the inside. So when they say it lies on the angle, or it lies in the interior or exterior of angle, this is just what they mean. Inside or outside. That's all that means. So if you look, this is often what happens. You have a mishmash of angles and points and every manner of thing that can happen when you have lines intersect. So name a point on the exterior of DEB. Well, let's look at where DEB is. So you're starting at D, going towards E, going up to B. So DEB is going to be this angle right here. Okay, so you're looking for an angle. So you're looking for something outside of that angle. So, and that's fine. So I'm looking at, well, you know what? G is right here, and F is right here. Either one of those would be fine. So I could say G or F. That's what I'm looking for. G and F are outside of the angle, and there's never any danger of them being either inside or on the angle. So name all the angles that have B as a vertex. There's quite a few of them. So B is my vertex. So what are all the angles where that kind of start from B? Well, I'm looking right away. I've got angle ABG. Okay, and I could have easily said it GBA. Okay, same thing, whichever you're comfortable with. I could also say, see how they're numbered there? I could also say angle 5, angle 6, and angle 7. When they're on the interior like that and they are numbered, that's usually a pretty good indication that they're naming the angle by a number. Okay, number 3, name the sides of 5. So angle 5 is right here. Angle 5 is right here. So I've got to be very careful. Okay, so angle B is my vertex. And if it's sides, then I need 2 rays. All right, so I'm going to say ray BG would look like that, and ray BE would look like that. So that's going to be my solution. Now, I will warn you that people will say, well, it's just GB and EB. That is incorrect. Okay, the sides of an angle are rays. So I need rays for my answer. Now for number 7. What's another way to name angle 7 here? Well, an easy way to do it, well, you can't really call it angle 7, but if I look, you know, angle A is up here, angle B is right here, angle D is right here. That represents the same angle as 7. So I'm just going to say angle ABD. And that's enough. That's enough. That's enough to tell me. I could flip it around and say DBA. Please note, vertex is in the middle. Okay? That's got to be there. So, how do we talk about angles? Okay, so how do we look? Anytime I've got this little square, that tells me right away that it is a right angle. And it's going to be 90 degrees. So anytime you see a little square, you can automatically assume that's going to be a right angle. And you're going to see that a lot. Okay, those pop up everywhere. So for this one, if you notice, it's smaller than 90. So we call that a cube. So the measure is going to be less than 90 degrees. Pretty simple. So the next one's going to be obtuse. Okay, so this is, if I drew like an imaginary 90 degrees here, it's going to be bigger. So that means it's going to be between 90 and 180. Okay, between 90 and 180. And this last one over here on the right is you know, we would call that a line, and you're not wrong, but this is called a straight angle. Okay, technically it's a line, but if we thought about it in terms of an angle, it would be a straight angle. And that measure is just going to be 180 degrees. Okay, so we have exactly 90, we have exactly 180. We have smaller than 90, and we have bigger than 90, but smaller than 180. Okay, and so these are terms that, especially acute and obtuse, and straight angle, which pops up every once in a while, that you have to keep straight. So now as we look, again, a whole bunch of angles mixed together. So let's look at SYT. So you start at S, go in towards Y, go out towards T. So now without knowing any actual angle measures, without getting out a protractor and measuring the actual distance of an angle, we can, just kind of going by eyesight, which is not something I love to do, but we can make an educated guess that, yeah, this is going to be less than 90 degrees. Okay, so it's going to be less than 90 degrees, so we're going to call that acute. SYX, okay, so SYX, so if I start here, start at S, go in towards Y, go back out towards X. So this is quite obviously way bigger than 90. Okay, so that one's just going to be obtuse. And just as kind of a sidebar here, whenever you have this, so the combination of SYT and SYX, if you notice that between the two of them, you create a full line, that's known as a linear pair. And we'll speak more about that in a little bit. Sorry, that's not SYT, that's SYX. Apologies. So these two together make a line, okay, make a straight angle. So that means that they're going to be a linear pair. So, another term to be familiar with, an angle bisector is a ray that splits an angle into two other congruent angles. So it's a ray. So here we have ray XY, okay, and it splits angle WXZ into two smaller congruent angles. So, and this is often denoted by these little tick marks. Those tell me that those are congruent. If two angles have the same little mark, that tells me that it's going to be congruent to each other. All right, so XY splits WXZ into two smaller parts. So if I look, KN bisects JKL. So let's see, KN bisects JKL. So that means this one and this one are going to be equal. So they say JKN, so JKN is 8x minus 13, and NKL is 6x plus 11. Figure out what JKN is. Okay, so now because it bisects, these two things are equal to each other. So now it's just an algebra problem, two-step algebra problem, which you've seen. Done many times, done several times, even this unit. So that becomes 0, 26, 2x, and 0. So a little division. X equals 13. But again, that doesn't answer my question. The answer is, what is the measure? That's what that M stands for. Okay, what is the measure of JKN? Well, I'm going to take 8 times 13 minus 13. So 8 times 13 minus 13 is actually, if you wanted to be clever, it's actually 7 times 13, which is the same thing. And either way, you're going to get that to be 91 degrees. I know. This says 91 degrees, but clearly the angle is smaller than 90. So just go by the numbers. Don't get locked into a picture or what it looks like. That's not a good reason to say one thing or the other, unless I'm specifically asking you for that. Okay. So here we're gonna have to draw something out. QS bisects PQT. So let's draw PQT. Okay, so we have an angle. Call that P, call that Q, call that T. So we have this angle. Okay, it has sides QT and QP, and QS bisects it. So, we'll eyeball. We'll give our best effort. So that's QS. So PQT, this whole big angle, is 6x plus 4. And TQS is 7x minus 2. How can I kind of figure out what is PQT? Well, I have to realize something, that if this one is 7x minus 2, this one is also 7x minus 2. These two combined equal that. So I'm going to go 7x minus 2 plus 7x minus 2, and that's going to be equal to 6x plus 4. So what happens now? Well, I do a little simplifying. 14x minus 4, 6x plus 4. So now it's back to algebra skills. So that's 8x equals 8. So x equals 1. Very nice. Very handy when I can do that. So PQT is 6x plus 4. But we know that x is 1. So that whole thing is going to be 10. 10 degrees, as it were. Okay. Boils down to this concept of a bisector. Realizing that QS is going to bisect. That means it's going to cut this in half. And the two pieces together are going to be equal to the big one. Okay. So be very picky, be very detailed about how you name things, about how you keep things in order. And please don't forget to do the assignment and to do the quizzes until you get 100%. Good luck.